Okay, another empirical formula problem. We're given the percentages. Again, with these percentages, we assume that we have 100 grams of compound, which basically turns these percentages into grams. So if we had 100 grams of compound, 31.9 grams, for example, would be potassium. First thing we want to do, if we want to figure out the number of moles, so we'll start out with 31.9 grams of potassium. We'll figure out the number of moles of potassium. Grams of potassium go on the bottom, moles of potassium go on top. Relationship: 1 mole is 39.10 grams of potassium. That's the atomic weight. That comes out to be 0.816 moles of potassium. Next, we've got the chlorine, and we're starting out with 28.9 grams of chlorine. Grams of chlorine go on the bottom, moles of chlorine go on top. Relationship: 1 mole of chlorine, 35.45 grams of chlorine. It comes out to be 0.815 moles of Cl. And the last one, 39.2 grams of O. Grams of O go on the bottom, moles of O go on top. 1 mole O is 16.00 grams of oxygen, and that comes out to be 2.45 moles of oxygen. The next thing we want to do is take these and divide through by the smallest one, which is 0.815 here. So looking at the potassium first, we've got 0.816 moles divided by 0.815 moles. And that comes out to be 1.00, so that's for the potassium. And we know for the chlorine what's going to happen is we've got 0.815 moles divided by 0.815 moles, and that will definitely be 1, and that's for the chlorine. And then for the oxygen, it's 2.45 moles divided by 0.815 moles, and that's going to be 3.01, which is going to be rounded to 3, and that's going to be for the oxygen. So you can see that the ratio we're going to end up with here is K is to Cl is to O will be 1 is to 1 is to 3, which is how we end up with our formula KClO3.